so much, sir.
Good afternoon, everyone. Let me give you the greetings, the typical Indian greetings, the greetings of what I've been taught from my childhood. Namaskar.
Namaste,
And
sir.
Assalamu alaikum, Satyakal ji, Namaste, Vanakam, whatever I could remember, I've uttered it. Um, Today's topic that I'm going to talk about is the challenges and opportunities of electric vehicle. Before I start this, I wanted to mention that India is a great utilizer of vehicles, especially in transportation sector. India is looking at two-wheelers, three-wheelers, four-wheelers in great potential for electric vehicles in India at the moment. I have to admit that electric vehicles has not been all that popular in Australia as of today because the price of petrol has gone down dramatically. Our petrol prices have become half of what it was before COVID. So unfortunately, I see that in India for the last 10 days, every day you have got 2 rupees increase per liter of your petrol. So you have increased your petrol price in last 10 days by 20 liters, whereas we have decreased our petrol prices from $1.50 to about 70 cents a liter now. So we have gone to half. So this is, I wanted to make sure that you understand this because one of the greatest reasons that we have this use of electric vehicle will be because of the petrol prices and naturally greenhouse gas emissions, carbon emissions, etc., and going for something which is environmentally friendly. But no doubt about it, customers are very concerned about pricing. So price, remember that price will be a very important factor when you decide to buy electric vehicle. That's number one. Number two problem we have got with electric vehicles, and I'm starting with problems rather than giving you the opportunities. You might laugh at this, but it's better to know what the problems are before you actually see the opportunities. The biggest problem we have in electric vehicle is there is no sound. It's completely quiet. It is very peaceful. And people are scared to drive something where there's no sound. They're used to these huge racket. In India, we hear the horn all the time, isn't it? So this racket is not there. And therefore, now we are looking at, I mean, can you understand from research point of view, we are looking at how to incorporate sound in a soundless vehicle. So that is a very stupid thing to do, but we are doing it because that's what the customers want. So can we go to the next slide, please? If you look at the next slide, it gives you all the topics that I'm going to talk about. But I don't know whether I'll be able to complete the whole thing within the time. If I can't do it, I'll skip the Berlin portion. I might talk about the Australian initiative and India and electric vehicles more than talking about the European one. Next slide, please. So let us try and see, what about electric vehicle? That means we want to shift from the IC engine to the battery. We want to go from petrol to electricity. We want to see that how we can manage this large load that will be imposed on the electrical sector. And we want to know, how does this impact the electricity sector? Naturally, the load demand will increase dramatically. Every one of us will be trying to charge our batteries in the night time after we go back from our office. And if all of us do that in our off-peak charges, the demand will go very high in the off-peak time. So we'll have to look at a new way of tariff. And tariff will not be the same as it was before. We may not have off-peak period and on-peak period, peak charges and off-peak charges anymore, because the off-peak also there'll be a maximum requirement because of the battery charging. So you'll find that there will be ways of charging. You will plug your vehicle for charging purpose, but you may not be able to charge till your time is allocated to you. So, and that time could be, say, between midnight and 1 a.m. And for Dr. Jain, it might be some other time. For Dr. Dugaya, it might be for another time. Everyone will have different timing where they can charge. So, is this electric vehicle going to be a help or hindrance? Next, please. Now, let me tell you how many vehicles we have in Australia. I don't know whether you understand this or not. When I came to Australia about 38 years back, the population of Australia was 21 million, 38 years back. Today, the population of Australia is 25 million. Okay. When I left Kolkata long time back, at that time, the population of Kolkata was 11 million. Today, the population of Kolkata is 30 million. So can you see that we have not increased our population, but look at the amount of electric vehicles we have. Sorry, look at the amount of vehicles we have in our Australian road. It is only 7 million less than the population that we have. Majority of them, around 75%, are passenger vehicle. And then the light commercial vehicle is only 15%. The fuel efficiency is about 19 kilowatt hour per 100 kilometers. So this will add 8% more to our electricity consumption, which means that in 7 years' time, we will double our consumption. Next slide, please. Now, look at this. How much time does it take to fill up your car? If you look at 40 liters small 4-cylinder car, it takes about 2 minutes to fill your car. And that's very important. This is what you do. You go to your petrol station in Bhopal and you fill your car in 2 minutes. And that is about 12 megawatt consumption. And let us look at the next slide. Yes. So you take about 2 minutes to fill electric cars, and I'll come back to that in a minute. Now, we have done so many studies about electric vehicles in Australia. This is some of the reports that I'm showing you. We are looking at electric vehicles. We thought that by now, majority of our passengers' car would be electric. Unfortunately, it has not happened. But we know for sure by 2050, all our cars will be electric. And we are very keenly looking at what impact this will have in electricity sector, because we are looking from getting away from the fossil fuel plant, which we currently have. About 78% of our energy comes from coal-fired plant in Victoria. And we are looking at 100% renewable by 2050. So there are a lot of constraints coming into our system. On one side, we are going from fossil fuel to non-fossil fuel, environmentally friendly. And now the other imposition is that we need electric vehicle, and the consumption has gone up dramatically. Next, please. There are 4 types of vehicles. The traditional one that you have, which Dr. Jain drives from her home to Sage every day, that is the one she uses, IC engine. Then the one that I'm would like to talk about is the battery electric vehicle, which is the pure electric vehicle. And in between, we have got the plug-in hybrid and the hybrid one. Hybrid one, we have many of them. We started with petrol and gas, petrol and diesel, diesel and gas. We are now looking at petrol and batteries. We're looking at all sorts of combination there. But the best one is going to be the battery electric vehicle. Next, please. Now, what are the factors? Next, please. What are the factors which will affect it? What will affect our electric vehicle in? I think first thing that will be affected will be the green credentials. And naturally, there are many of us who are very concerned about the environment that we live in. We want clean air, especially in Australia, where we are very concerned about environment, about our health. And because we are living under the ozone layer, we are the closest to the atmosphere in the whole world, and we will all die of acid rain if we are not careful. So we want green energy. Then, no, please go back, please. Go back to my last slide. Yes. Look at charging infrastructure. Have we got charging infrastructure? We're used to driving very far. Like for me, I have driven many times from Melbourne to Perth, which is 5,500 kilometers. And I do that. I love driving. I go to Darwin from Melbourne, which is about 2,500 to 3,000 kilometers. And it takes me 3 days, 5 days of driving. We love driving. Now, with that sort of distances, will our car be able to survive? Do we have any charging station in between? The answer is no. So Australia has built in charging station at the moment between Melbourne and Sydney. There's no problem. We already have around 20 charging stations between Melbourne and Sydney. So there's no problem driving from here to Sydney. Driving from here to Sydney is about 800 kilometers, which is roughly like Calcutta to Patna, something like that. Now, then the range of vehicle, how long will I be able to go before I need to charge? Will my vehicle range be 60 kilometers, 100 kilometers? How much can I, what is the range? Then fuel prices, that's a very big factor. Fuel price, the price of the fuel, I told you right in the beginning. With $1.50 a liter, I will show you, it is very profitable to go for electric vehicle. But 75 cents a liter, I won't go. You understand that the fuel price is a very important factor. And then at the moment, there is no constraint globally for fuel, but before COVID, we did have a lot of constraints. Then the price of the vehicle. Remember, and I'll show you, the price of the vehicle are pretty comparative at the moment. You can get vehicle between 40 to 50,000 Australian dollar if you want to go electric. In the past, that same car was about 150 to 200,000 dollars. Even now, Tesla cost is 200,000 US dollar to buy. Next. Okay. Let us look at the constraints. We have got huge amount of electric vehicles, and but as I told you, there's very selected amount coming to Australia because Australia is not accepted it wholeheartedly. It is more acceptable in Europe and other parts, in China in particular. So we have to look at the supply constraints, which is affecting our growth. Next, please. Next. Yes. Let us look at some of these cars. This is a battery one, which is a Mitsubishi one. It has been produced in Australia itself. It is available now at about $48,000. And the range is between 90 to 150 kilometers. Okay. Now, this car is a small car. It will fit in very nicely Dr. Jain and her husband and a small dog or a small child, but it's very hard to fit me. It's a very small car, right? I like big cars. So, I mean, I would take it. I was very disappointed with this car. Next, please. Nissan Leaf. Okay. This is also battery. The range is better, 100 to 160 kilometers. It seats 5 people. It's like any normal sedan, available now at $30,000. And this tells me that you can get prices in that. This compares with our Holden Commodore. This compares with our Ford Falcon. The prices are no more than Ford Falcon and Ford and GM Holden. So I'm going for the basic model. Those ones which are the IC engines are more expensive than this Nissan Leaf. Next, please. Look at Holden Volt. Again, this is planned for Australia. This is a GM product. Okay. However, this has 60-kilometer range. If I were to look at this Holden and a similar Holden in a petrol one, this is 3 times more expensive than the petrol one. Next. The Renault. This is a very compact sedan, is a French one. You can swap the battery in 4 minutes. The range is pretty good, 185 kilometers. Price is around $40,000. And this performs like a real car. It is not a Mickey Mouse. And it is much similar to the car that I'm used to now. Next. This is the battery one. This is the car that I like. If I was young and getting married, I would ask my father-in-law to give me this as the jahez or dowry. Okay, $200,000 available now. A second hand will cost me $100,000. The range is 394 kilometers. This is the Tesla Roadster. Next. Look at the Model S. This is another one of Tesla. Okay. And this is a sedan. The range is much better, 500 kilometers. Okay. And depending on the battery, it is anything between $60,000 to $100,000. And the review is better than Porsche and Audi in California. People are preferring Tesla S model to Porsche and Audi in the United States. Next, please. This is the other one I like. This is the battery electric vehicle, the Model X. This is a 7-seater, 500-kilometer range. Okay, slightly more expensive than S, less than the original Tesla that I talked to you about, Roadster. Around 100,000, I can get this car. Next. So I showed you so many of them. I think Tesla is going to bring a new model, and that will be costing you $30,000 within the next 3 to 4 years. It will be a Gen 3. They are merging with Apple. They've got superstar charging station across Europe. In Germany, in Autobahn is all there. Half of Germany is covered, and it charges about 30 minutes every few hours is what is required. Next, please. want to talk about China. I know it's not good time to talk about China in India at the moment, but I will talk about it because we are looking at the technical side. Now, in China, they had huge air pollution problem. If you think Delhi is bad, China was horrible, Beijing was horrible, and they have controlled all their pollution. They have gone to e-mobility, where they have got e-bikes, they've got e-cars, they've got e-buses. They're in mass production. And therefore, because of that mass production, the cost has reduced dramatically. Next, please. Now, this is what I was trying to tell you about. Look at the price of the IC engine compared to electric vehicle. Look at the price of petrol when it's $1.50 per liter. For 100 kilometers, it is going to cost me $11.25. Whereas the electric vehicle will only cost me $5.70, or if I'm using off-peak, it is going to cost me $2.30 for 100 kilometers. However, as I was telling you, the price of petrol has gone down to about 50% of what it was before COVID. So now if you look at that same thing, the price of the petrol car is about $5.60 per 100 kilometers. So compared to the electric vehicle, unless I'm doing off-peak charging, if I'm doing peak charging, my petrol car still comes better than electric vehicle, subject to that price remaining 75 cents. I believe that the prices are going to explode just after COVID. Next. Then look at the petrol prices. As you see, the carbon prices, okay, are completely favoring ICE vehicle, right? You find that you look at it, if you have got high prices, what impact it is having, what the clean energy future is, which is that green curve, and if you look at the blue one, that is the global action we need to take. So we have to look at the electricity prices. Next, please. So the electricity prices are going up. The fuel prices were going up. So it made a lot of sense to go for electric vehicle at that time. Next, please. Now, life cycle cost. If you look at this curve that I've got, if you look at the battery one, look at that from 2010 to 2030, the life cycle cost has dramatically dropped. Whereas the internal combustion engine, the blue curve, has been steady throughout. So the battery one prices are going down. This is for a small car. For a high kilometer small car, that was small car, low kilometer. For high kilometer small car, we see that even there, the battery prices will go down substantially to about 20 cents per kilometer compared to $1.50 per kilometer. So if I'm going in a highway, the price is much cheaper. If you look at it, it is 20 cents compared to $1.50 in a city condition. Next, please. If you look at the range, naturally, I told you the best range is the Tesla Roadster, but I can't afford it because it's $200,000. But if you look at down the curve, you find that there are many cars which are there where the prices are ranging, where the range is between 80 to 160 kilometers. And if that is the range, majority of our trips can easily be solved. And we can see that you can easily use it by charging it every 3 days or something like that. Majority of the people in India would not be driving more than 40 kilometers per day. Next, please. The vehicle trips, most of our trips are less than 5 kilometers. You're going from home to the university. You're going from home in Bhopal to Sage. 90% of our trips are less than 30 kilometers. 99% of our trips are less than 120 kilometers. And this is, if you look at that 120 kilometers, all of them is in the range of our electric vehicle. Next, please. Charging infrastructure. This is going to be an interesting one. I can do my charging at home or my commercial premises or any public charging facilities, a car park or something like that, using level 1 and level 2. Level 1 is a standard charge, which takes about 6 to 8 hours for a total charge. Top up will take me about 2 to 3 hours. Whereas a fast charge, the total charge will be 2 to 3 hours and the top up will be 30 minutes. Level 3 will be the one for quick change facilities, which is the rapid charge, and the total will be between 10 to 20 minutes, and top up will only be a few minutes. And that rapid charge will be the one that many people will be quite interested in. Next. Okay. How can I charge with a standard 15 amp plug? You can have it installed by an electrician. You need to install a second meter. It'll depend on the site. That will be told by your EV charging infrastructure providers what sort of commercial arrangements are there. But if you look at it, you can do a bollard one, you can use a wall-mounted one, or you can have a domestic one. Whereas in the charging station, whether it is in a petrol pump or whether it is in a car park facilities or whether it is in Sage, you will find either a bollard over there or pole mount or wall mount or domestic type. Next, please. So, as I said, you need to have into consideration how much it is going to cost you to install this. If you're looking at a basic indoor one, it'll cost you anything between $2,800 to about $4,000. Whereas the outdoor one would cost you $2,800 to about $6,500. You can have it on a domestic garage, you can have it in a car park, or you can use it in the on-street bollard. Depending on where you're going to use it, the installation cost will be different. It could be anything between $600 up to $10,000 plus. Next. Okay, look at the greenhouse emission. Compared to your ICE, internal combustion engine, which is in blue, compare blue with the purple one or the red one. The red one is the electric vehicle. Look at that. The greenhouse gas emission is much lower than the IC engine one. So if you look at it carefully, you can find that you can use 100% green power for your EV. Next. Individual vehicle might vary. Okay. Nissan Leaf might have more greenhouse gas emission compared to Mitsubishi one or the Holden one. It all depends on the product that you have bought. Next, please. This is not as good as walking or cycling or public transport. EV is not going to address your Delhi's traffic problem. It is not going to affect your parking problem. In Bhopal, you don't have any parking problem. So there's not a big issue, but in Delhi, you do have problems. This will be embodied energy in the battery and car components. Next. So you have to look at your transport system. And if you look at the transit services, you'll be carrying your e-bike. Look at that. I'm carrying my e-bike in the public transport system. That is the normal tube, which is an autonomous vehicle, and it's like just an alternative to private car. And if you look at it, even now, the battery electric vehicles are outperforming internal combustion engine, especially in high use. So you will have electric freight, electric buses, electric ferries. In Melbourne, we've got electric trams. So there'll be a lot of rapid recharging stations required, and you will be requiring catenary charging on main routes. So there will be different impacts naturally. You have to be careful that what type of impact it will have, because our trams run on 720 volt DC, and we've got 22 kV supply coming over there. So we have to look at either 22 kV or 6.6 kV, transform it, use the inverter, bring it down to DC, and then use it for 720 volt DC to charge our trams. So there is a lot of opportunities, and we can do controlled charging. Next, please. Forecast. No, next. Now, if you look at my forecast, I tell you first thing, electric vehicle will definitely go in. I tell you in Melbourne and in Australia, we have not done that as much as we expected. I had expected by now we would have more electric vehicles, but unfortunately it has not taken place. But there is no doubt about it. We have, even now, we have a lot of hybrid cars. But these hybrid cars are there because we got incentive from the government to install, because we'd like to drive 6-cylinder cars. We like big cars, 400cc, 600cc type of cars. And therefore, the government gave incentive to put a gas cylinder. We use LPG, unlike India where you use LNG or something like that. So, if you look at it, hybrid cars are very common. That was in about 5 years back. Now, more or less, you will find hybrid car is being replaced by plug-in hybrid. And if you look at it carefully, by 2030, we will have more electric cars than the hybrids. Next, most of the hybrids will be becoming outdated and it'll not be cost effective. So what are the costs? What are the impacts? What are the imposed? Naturally, we will have to have a new management incentive, because everyone is going to charge in the night time. We'll have big problems. We'll have to have special cluster. That will be the spatial cluster that we'll have, which will be the early adopter community. Then the size of vehicle, then the hybrid uptake. All these things will have impact on the electricity sector. Next, please. So, if you look at this chart that I've got chart of 5 of our states. They're looking at the maximum coming in from New South Wales, the green one, at about 6:30 p.m. This is in 2010. If you look at Victoria, the orange one, which is just behind New South Wales at 5 p.m. This is a different time zone. In Australia, we've got 4 or 5 time zones. And you see at different times, the peak are different. Next, please. This is the national electricity market. The national electricity market says that if we don't have our system managed properly, we are going to have huge issues in the additional peak demand, because we will find that we will have unmanageable charging of about 8,600 additional megawatt that will be required. And the time of use charging will only be 400 megawatt for a small smart charging system, which will have another additional 205 megawatt. Next, please. So if you look at, again, at the additional peak demand that we will have, according to our national electricity market, it depends on whether we have got a low or central or high type of demand, and it will tell you what is the forecast that we have got. Next, these are all the modeling that has been done. So the additional cost is going to be, in majority will be in the distribution area. 2/3 of that will be in the distribution area, and it'll cost $10,000 per electric vehicle, and this will be unmanaged charging. Next. Okay, so the early adopters, who will be the one who will take it early? It'll be people like Dr. Jain, who get a lot of salary from Sage, right? They are the higher average income people. They've got huge amount of education behind them, PhDs and other things. They are above the average technological skills. They are very aware of the environment. They are aware of new technology, and they want to take this. So most probably the early adopters, okay, will be the one who will be the non-average people. They will be the one who are the high income people. And then after 2030, there will be the majority of the people will be coming in. Next, please. Okay. There will be, in Australia, if you look at that blue thing that is there, this is the eastern part of Australia. And if you look at it, middle is absolutely desert. It is worse than Kalahari and Sahara Desert. And only the population lives on the eastern part. And if you look at it carefully, 85 to 90% of the people are on the eastern side, and only a 10 to 15% people live in the western part where Perth is, whereas majority of people are living in Sydney, Melbourne, Brisbane, Adelaide, and places like that. So you will find, because they are the majority of the people, the grid will have more impact on the eastern part of Australia than on the western part of Australia. Next. Additional challenge. What happens if level 2 charges become standard in home? Can our distribution network take that? Upgrades will be expensive, particularly if we have to put underground lines. In Australia, it has become a fashion these days that we do not have overhead lines in our main cities, especially in CBDs and newer suburbs. We've got underground lines. So that will become an expensive features, because that will be a doubling on the cost. Next. Okay, as such, we have got huge amount of overload in our system. Okay, this is how the system is. Look at our 400 volt distribution line is already loaded. It is so loaded that some of the lines go about 200, 250% overload. And if plug-in vehicle will come in, that overload becomes very high. And that is the scenario we will have if it is 100% e-mobility is there. Next, please. Okay. Now my question is that, can we accommodate this? And if you look at an example of South Australia, where we have done the modeling, I think that it can be done, provided you do it in an off-peak time. Look at the peak time. The load automatically from 8 o'clock onward in the morning up to about 9 o'clock in the night is already high. And South Australia electricity system cannot cope up with that. Whereas in the night time, from 10 o'clock up to about 6 or 7 in the morning, there should not be an issue. Off-peak charging can be accommodated. Next, please. Okay. If you have high cases, you're going to have reduction in retail tariff, because of the high intake, and all our states are different. If you look at the last three, which is New South Wales, Victoria, and Australia, the last three bars that I've shown, if you look at that, look at the improved load factor that we will have because of the retail tariff will be different depending on the time. But this will happen only if we can manage our charging time. We will not allow everyone to charge at the same time, but they will be going at different times. Next, please. Okay. Now what will happen? And I told you by 2050, we are telling you right now, we are 2050, we will be 100% renewable. Then we will move to 100% EV. Okay. What will happen? There are two scenarios. One is a scenario on your left-hand side, which talks about the IC engine, and the right-hand side talks about the electric vehicle. Look at what happens on the buses, on your vehicle maintenance, on your vehicle capital, on replacement charges. Next, please. So there's be additional load. Look at that load that we are going to have. We are going to have that additional load. Then that additional load has to be managed. Therefore, we can't allow everyone. See, the demand becomes much greater than the supply that we have. And it all depends on the time of utilization. Next, please. Okay, choice. Let's see this. Let us see. Next, please. There are a lot of supply chain, okay? And as has been defined by our Australian Electricity Market Corporation, there are a lot of projects in the market. And if you look at the one that I have put in red circle, this is the choice review, and that's the power of choice. Now I have a power to buy power from Madhya Pradesh or from Kanyakumari. I can buy power from West Bengal State Electricity Corporation or Madhya Pradesh Electricity Supply Corporation, depending on where I want to. Now, after that, there will be a review of electric vehicles, and we'll have to find out what is the most economic, efficient way to manage the impacts of electrical vehicles in the market. And that will have tremendous amount on our retail market. Next, please. Okay. We know that DSP can directly participate in the wholesale market. We can make our consumables with multiple parties. Then we can look at coordination between various policies for E and DSP participation. Next, please. Okay, time varying, the one I was talking to you about. Not all of us will be able to charge at the same time. We have to look at our consumers' bill and which will be the most cost reflective. Look at the cost related to peak demand. Encourage customers or retailers to respond appropriately. And retailers will have the free choice to decide how to include this in the offer of the retail prices that they are incorporating. Next, please. So, the electricity price, 80% of our cost will be time varying, 37% of that will be in distribution, 35% in wholesale, and the rest will be renewable, retail, state-based scheme, or transmission. Next. Therefore, we are looking at the time varying network. Look at that. The consumer which are affected depending on which band they are in. The band 1, it is mandatory. Consumer will be moving to a time varying with network tariff. Band 2 will be, consumer will be deemed to be on a time varying network, and the band 3 will be, consumer will be deemed to be on flat network tariff. So it will depend on which band they are, and depending on that, they will be allowed. So most of our small to medium residential and small business consumers will be in band 3, where the price will be more or less fixed. The large and medium residential and small business consumer, here they will have a flat network tariff, whereas the band 1, where the large residential and small business consumer, here it will be decided on the impact of time and depending on the network tariff. Next, please. Vehicle to grid, V to G. Next. There are large numbers of grid connected batteries. Okay, we have installed 100 megawatt in South Australia. It was done by Elon Musk of Tesla. He did that in 90 days. He built this 100 megawatt of battery storage. So this is being used as a backup for our renewable energy, which is 40% in South Australia, and is used as a distribution storage. And we are now integrating with all the renewables, and they are charged and managed. And here we do V2G, where we supply energy back to the grid. So from the vehicle, you're going to use the vehicle as a storage device, which will be supplying, besides the battery, it'll be the vehicle itself will be supplying to the grid. Next, please. What will be the factor of success for V2G? It'll be impact on battery life, where manufacturers will be concerned. There'll be a direct concern because there will be return to discharge vehicle. Tariff arrangements will be there. We will award higher tariff for vehicle to grid than the consumers pay. And the aggregation services will be the critical mass of the electrical vehicles. Next, please. Okay, possible areas of storage. Can I stop for a minute? Dr. Jain, I have crossed my 50 minutes time. Will you allow me another 15, 20 minutes? Dr. Jain, are you hearing me? Dr. Saxena, my time officially is up. Dr. Jain told me to shut up.
So you can extend up to 12:15. We'll be love to hear you.
Okay, so another 10 minutes I will take. I think. Can you skip some of these? Can you skip some of the slides, please? Can you skip?
Sure.
I will tell you when to stop. Please skip. Please skip.
Sure.
Please skip. Please skip. Please skip this Berlin one. Please skip this. One more. One more. One more. One more. One more. Yep, this is the one. Go back, please. Yep, one more back. One more back. Yes. I wanted to show you some of the initiative in Australia. Next slide, please. In Australia, we are looking at new energy. This is our house. We expect that 1 million customers will be connected by 2020, where there'll be, this year we will have smart homes, we will have smart businesses, and the customer will have competitive and connected energy product, which will provide them convenience, comfort, and control. And every customer, whether it's a large one, small one, or just a commercial services, they will all have product. And look at the red, there will also be electric vehicle services, which will be allowed. That will be in addition to making our home very, very smart. AGL is our energy distribution company, and they are focusing on comfort, convenience, and control. So I, as a consumer, will have control of all my energy requirements. Next, please. Okay, this is how the plug-in vehicles will be. And in my garage, that is the garage, I will have a charging circuit. Look at it. I've got a distribution network which is connected directly to my distribution board in my garage, right? There'll be a charging outlet, and my electric vehicle, there will be a charging cable which I'll connect to the charging to my electric vehicle. Next, please. EV market is heading in the right direction. This is what our cycle is. Okay, we had a lot of expectation in 2011. We had a bit of trough. Okay, I think the technology is maturing, and we are actually coming to a plateau at the moment, and is becoming more productive, and therefore we see more usage of this electric vehicle. And market is the best driver and indicator that tells us that we are on track. Next, please. Okay, look at this. Our asset value will grow by 2020. We would have abated 0.1 million ton of carbon dioxide. By 2025, 1.7. By 2030, 6 million tons of carbon dioxide. We will have 36,000 electric vehicles in our state. And then asset value will go from now to about $11 billion. It will multiply about 10 times. And the demand will increase about 5 times purely because of the electric vehicle. Next, please. Okay. We are looking at all sorts of vehicles. Okay. All of them are interested. Australia is a very good market, whether it's Volvo, Audi, Renault, Mercedes. If you look carefully, the main people will be, they're looking at is Mitsubishi is looking at the maximum type of sale compared to Volvo and others. Next, please. Government fleet has we already have about 7,500 vehicles, which is government ones, which are all electric. They have got a substitution model. We've got a lot of Australian EV make or model mix, and I've given you all the prices which is there. And there are a lot of savings that could be made if it's business as usual, or if there is low attributes or high attributes. Okay, the connected EVs, it'll be either in the network, or there'll be a charging, or it'll be on system, or just transport or user. We need to integrate our system because we will have multiple domains and there will be productivity dividends. Next, please. Okay, this is our car which is there. This is AGL, which is a distribution company. Okay, they have this car roaming in the street of Melbourne at the moment. Next. So I want to give you a bit on India. When we're talking to India, I always like to talk about India. I love India. I am from India. So give you a bit on the Indian context. Look at the electric mobility over there, grid integration, and look at some of the field results that has been done in India, and conclude and do my recommendations for India. Next. Okay, India is not a small market. And I tell you, electric grids are a key contributor to future proof of energy, security, environment, and clean air in India. We have got National Electricity Mobility Mission. We have got National Smart Grid Mission. We have got renewable generation by 2022 of 175 megawatt. And there are promises of greenhouse gas emissions by 68%. Power is generated from coal, and we are looking at ways of trying to reduce our coal consumption. And you will find that India is just following China. We are just following China in our requirement for reducing our greenhouse gas emission. Next, please. Okay, some of the EV development that has taken place. Okay, you can see that a lot of rise of cars in India is there. Okay, but EV in general has increased, right? In California, it went to plugging an electric vehicle was much greater than any part of the world. Next, please. Okay, you find that 35%, can you go back, please? The 35% of global EV share is going to be in 2035. 10 times increase in California was EV in 5 years, 40 times in California charging infrastructure. Next, please. Okay, so look at this. This is what I call my VIC, or smart charging focus for grid integration. I was talking to you about V2G. I'm looking at V2X. It is vehicle to grid integration. It could be X, could be anything. Okay, V2G face internet inherent problems such as battery degradation, voided manufacturing warranties, battery electric vehicles, etc. And if you look at it, it looks like a bed. And if you look at on the left-hand side, there is less deep, whereas higher peak is on the front side. Okay, next, please. So we are not only looking at the transmission, we are looking at the distribution behind the meters, and we are looking at building. So if you look at, there's a whole issue of management of electric vehicle, charging of electric vehicle, and the grid domains. Next, please. So if you look at the DER integration, there is issues of interoperability and tools which are decision making, the grid, which is where the operation and market is, and three things which becomes very important is security, reliability, and resiliency. Your power system has to become very resilient. This is a new area of research which is coming up, resilient power system. Next, please. And if you look at some of the supply in equipment, there is lack of EV and EVSE. Okay, there is lack of interoperability in the network and electricity supply providers. You will find that the demand will be high, whereas the original grid will be, the load will be supplied in that green curve, but that blue curve is the one which is going to be the demand that will be required because of the EV and EV supply equipment. Next. Okay, then the workplace. The workplace charging, that is a very interesting one. Dr. Jain will come to Sage. Instead of charging her car at her home, where she will have to pay the bill, she will ask the Sagar Institute to pay the bill by plugging her car in Sage. Now that will embarrass Sagar Institute. That will definitely not be allowed. Dr. Jain, you are thinking about this, give it up. It won't be allowed. You won't be allowed. You can sell your power to your high voltage laboratory or power systems laboratory, but you cannot charge at Sage. Next, please. If you look, the user will be in the level 2 level, okay, where they will participate in the demand response time. So you will have possibility of having this charging station in Bhopal, and you will charge it by paying money, just like you pay in your parking meters. Next, please. Okay, some of the case studies that has been done in India, they have looked at grid distribution, they have looked at the infrastructure itself, they have looked at fast charging, they have looked at BEV driver, and they find that there is a lot of potential over there in India. Next, please. The open grid integration, this is also there. That is very similar to what has been done in United States when they are looking at onboard vehicle telematics. They have got demonstration going, looking at the original equipment manufacturers' electric vehicles, and they're looking at prototype. Next, please. Okay, some of the recommendation. Once more, please. Can you click once more? Yeah. Some of the recommendation. I think we need to have smart charging. So I'm proposing a V1G. Integration will be required, which will be market-based, dispatchable grid resource for viable variable generation. Interoperability and cyber security will be there. That VGI, which will be either V1G or V2G. Initially, as I told you, we start with V1G and then we go to V2G. This will give you the electric mobility. The national mission of India must consider technical and regulatory changes. That is where we lag behind. And we can only do this when we do case studies for India, not look at other countries and follow them. You have to make your own design policies, and then you can leapfrog on the EV ownership. The VGI lessons can serve as a model for India to accelerate adoption of EVs. We can look at decarbonization of our grid. We can look at improved urban air quality. We can look at intra-ministry coordination, especially MOHI and MOP and MNRE. I have worked with all three of them, and I find that there is disjoint over there. We must have an integrated clean energy and clean transportation goals. Next. With that, Dr. Jain, I have finished my presentation. Thank you very much for allowing me to speak to all of you in this wonderful multi-conference. I've enjoyed talking to you, and thanks for giving me that extra time.